So welcome. Today we are going to cover how to operationalize your OR tools model, and we'll be focusing today on decision workflows. Our presenter today is Marius on our decision engineering team here at NextMove, and I'm Renuka. I'll be your host for today. Our agenda is a quick introduction to NextMove and decision ops, and then the majority of our time will be spent with Marius in his demo, where he'll be walking through how to track external runs in NextMove, as well as deploy an OR tools model to NextMove, and of course, creating and managing decision workflows. We will save time at the end for Q&A, but throughout the presentation, please feel free to use the chat feature, the Q&A feature built directly into Zoom. Just make sure you toggle between hosts and panelists and everyone, depending on who you'd like to see your question. And we also have NextMovers on the call, so they are happy to answer questions on the fly as well. Okay, so let's dive in. NextMove is a decision science platform, and it's a platform that acts as the hub for all of your optimization work. So the platform accelerates decision science and data science teams with decision ops tooling. So that includes simple deployment to production infrastructure, a testing framework, model management, a system of record, and more. We also have optimization integrations with popular modeling tools and solvers like you see here, Gurobi, OR tools, Ample, Highs, Hexly, and others. And we also have decision app quick start. So just as the name implies, these are ways to get started very quickly with pre-built models that are built for common use cases like routing, scheduling, fulfillment, and more. So let's talk about decision ops briefly. The themes you see here are fairly common across other disciplines, so they're probably very familiar to you in the context of DevOps or MLOps. And here at NextMove, what we're doing is we're bringing that same standardization and that same transparency to decision science. So throughout the demo today, you'll see Marius kind of walk through each of these and how they accelerate workflows. So what does this mean for you and for your team? If you are an ops researcher, a decision scientist, data scientist, modeler, NextMove allows you to focus on the modeling piece and not have to be concerned about building or managing and maintaining tooling for decision ops. If you're a software dev, if you're an infra engineer, NextMove allows you to take that model built by your modeling teams and easily deploy that and monitor that as a service in your tech stack. And if you're an analyst or a business stakeholder, NextMove allows you to interact with and understand the value of your decision model through interactive reports and dashboards. Okay, so on to today's topic. Let's jump into decision workflows, also known as optimization pipelines. So whether you're using OR tools or other modeling and solving tools, the model doesn't exist in a vacuum, right? There are upstream and downstream steps required to operationalize the model in your systems. So essentially, that means model development exists in the larger context of other workflows. That might be linking to ML forecasts or adding visualizations. And let's just walk through these three examples here. The first one is fairly simple, solve and visualize workflow. These are the steps that would commonly be used: fetching data, running a model, visualizing output. The next kind of category example is linking and transforming. So here we see that we're running a model again, but in between, we're transforming the data to be used as an input for the next downstream model. And then our third example is a little bit more complex. We can see that our first step is fetching and splitting the data. So now we have multiple regions that are being solved concurrently before aggregating results and visualizing the output. These are just three examples of types of optimization workflows that you're probably familiar with. And linking all of this together is really powerful to an organization, but in many cases, it can be very manual as well. So you can see here, there's usually a person or a team involved in between each step to ensure that the next step happens. With NextMove, we provide tooling that streamlines how you configure, how you execute, and how you monitor these workflows. So once they're built, you really just have to click run and see all of these steps fire automatically. So we're going to take a look at how to create one of these today. And Marius is going to get us started with the problem setup that we'll walk through today.
Yes, thanks, Renew, and also hi from my side. Happy to have you here. So the first thing I want to talk about here is a little bit about the application actually. So we need something basically to solve so that this demo actually works. And what I picked today and wrote is like a very small MIP model using Python and OR tools that simply assigns or allocates a number of regions with a certain demand to a number of hubs, to a set of hubs that service these regions. And these hubs have a capacity as well, so we want to assign them. And if we go to the next page, we can also, or next slide, we can already see the assignment happening. So for example, we have like this red cluster of regions here with a little more saturated one in the middle, which is actually the one that's hosting the actual hub. And all of these regions get allocated respecting the capacities. And I won't go into the details of the MIP model itself, but probably a lot of you are familiar with either using OR tools for this or some other library. And what we're gonna speedrun here is the bringing this app that I just described, that's solving this problem basically, to the Nextmove platform in incremental way, and finally ending up with a workflow meta model kind of that wraps the actual model solving with some additional things that you might be interested in. But we'll get to that in the end. The workflow will look like this, and but let's start first with actually pushing the model the first time and things like that. So I should probably take over the sharing. Right, 1 second. And here we go. Okay, so basically I have the steps here on the right side again. I just introduced you to the problem, and then the next step is actually introducing the RTools model. I called it here, so I organized it a little bit as the model external, quote unquote, which just means that we just have the bare bones model here. And that means that there's nothing yet about this that is Nextmove. So you can see here among the imports also that nothing from Nextmove side is imported. We simply have a translation for the status, for example, so that it's more easy to tell what, whether we have an invisible solution or whatnot. Then everything kind of hinges on the solve method that actually does the MIP modeling, right? And redirects the data to the solver, etc. I won't go into details, but there's just a number of variables, constraints, and the objective here inside here, obviously. And then there's a helper function for determining distance as have a sign. And then the only part that we want to focus on today is this actually. So right now, this model is very simply wrapped by reading the input via standard in and writing the output to standard out. And in between, we solve. And that's really it. So the input comes from here, which is just the regions and the hubs. So if you look into these, there's every region has a demand, and then every hub has a capacity. So pretty simple. So let's try and run it first. So again, I'm in the same directory. I'm going to pipe the input JSON into the model, and I get a result, which is cool. Now let's see what actually the result looks like, just to have a brief look at it. So I'm just going to wrap it into the output JSON so that we can see it here as well. And you can see that we have the assignments. So all of the regions get assigned to a hub, and that's exactly what we want. So the next step is, and now this is kind of already done on the modeling side, done-ish, right? Now the next step is, well, you actually want to integrate it and use it, right? So, and that's where Nextmove platform is really helpful in many different ways, which I think, like managing the model version or collaborating on the model or on the runs that happen in production, and like adding a lot of things on top of it, including, for example, the workflow that we'll end with. But as the first step, actually, in bringing things to Nextmove platform, I think it's a good idea to use tracked runs, and I'm gonna introduce them in a second. But basically, start in console just quickly because we need to actually create an app. So assuming that you already created an account and logged in, you will have an overview of your apps and workflows that looks like this. I obviously work with this a lot, so I already have quite a number here. But I'm gonna create a new one just for now, and I'm gonna call it, let's say, demo app let's use 7. I created other ones in the past, so I don't want them to overlap. So I think 7 is free. Anyway, this should be really clean and nothing in it, right? No runs, nothing. And I can already go back here to my actual code. And now what I want to introduce is tracked runs. For that, I need to have the API key, which I already exported so that I'm not accidentally leaking it. I need to import some things from some Nextmove dependencies, which is basically just Nextmove Cloud, because there's a sub package in it. And then, oh yeah, I wanted to also track how long it ran, so to have some statistics. Yeah, but what am I doing here? I'm basically creating a client to interact with the Nextmove platform. Then I'm creating a version of my app, basically, or instantiating it so that I can interact with it. This app I just created on console side, right? And then I'm just adding a track run. And what does that mean? It basically mirrors the run that is happening locally here on my machine. And also, I don't want to output the data here anymore. So I'm gonna comment that out. And then, yeah, I'm sending up the input data, the output data, some additional statistics like the duration, for example. I can even bundle logs or other things. And then the only thing I'm gonna log here is the run ID and the console URL. So let's just go here and run it again. And what is happening now is basically it's solving still on my machine and bundling everything up so that it gets reflected and I can look at it on the platform side. And you could ask, yeah, well, what does that help? I think that's a great introduction to using the platform, because you can use a lot of the other features that you uh, would use if you have actually a model running on our platform. But not only that, you can use it for bookkeeping of your runs, for example, for sharing, obviously, because it's always helpful if you work with others to share things. So, for example, you can look into the input here. You have that tabular view, but you also have the raw view. So basically here you can see our assignment, right? So basically region to hub. And then you also have the raw view where you actually can look at the JSON. And you can share all this by just clicking this button with a colleague, right? And then they can also download the input and output and can do their analysis on top of that, and so on and so forth. And obviously also get the run history. So our run is popping up here and categorized as type external, because it actually didn't happen on the platform. So that brings us back to our flow. So the next step is Nextmovifying the model. And for the sake of time, because this is rather short today, I already have prepared this and will quickly walk you through how to wrap this model into like a Nextmove app, I would say. And for that, the typical approach is there's multiple ways that you can find in our documentation actually, but the typical approach is simply to add an app.yaml that defines, like, this is a Python app, for example. This runs in a Python runtime. There's actually only the main.py file that we're interested in, and some requirements. The requirements right now is OR tools, obviously, and Nextmove. And then the input JSON is just copied from the other folder, and then we can go to the main.py. So how did this change? I promise you, I didn't touch this code at all. So the code here that I already folded away that you saw in the other file, right? That is just the same. What I replaced though is the wrapper. So the wrapper is now using this decision model class, which is like helping you in other ways. Theoretically, also, again, there's different ways of doing this, but this would be the recommended way. So we have a solve function that we want to satisfy. And the signature is we receive an Nextmove input and we write an Nextmove output. And you can see the solve function we had before, and we're simply forwarding the things like the solution and some statistics into the Nextmove output. And yeah, mainly that. And there's also the main. I don't want to get lost here too much, but one thing that I find actually really interesting is this one, which is the options. So we can define options here for our app/solver/model. And that is, for example, setting a maximum duration, for example, is a typical thing in operations research, right? And that thing, the interesting part about this is like using argparse in Python, but on steroids a little bit, because this option will basically be surfaced outside and everywhere where you consume this app. So you can actually control this from the outside. You can set defaults for these options and other things, right? And that helps a lot also in experimentation, right? So you can run experiments on our platform, and then you can range over different sets of options. For example, if you want to fine tune some parameter, want to do a scenario experiment, etc. Not a topic for today, though. So yeah, so I next movified the model. What now? Well, I need to go in here and push it, and then I can make a first run. So let's go to the other directory. Let's clear this up quickly. And again, this is the directory that we just saw. So we are gonna next move app push -a, and I called it demo app 7, right? I hope. We'll see. And what will happen is basically we're gonna push it over to our platform so that it's available here. And so it's gonna bundle all the dependencies and all the files, everything into one neat artifact. And then we can start make runs against it. And the difference now will be, in principle, it looks basically the same. I could even look at the output here directly. I won't though. But basically, yeah, it's the same like I ran it locally, but instead this time it's gonna run. I'm getting lost. Focus on typing first. Okay. So getting the input into a next move run. And now this run obviously didn't happen on my machine, but this run actually came up here and ran here and was actually very, very quick. It's already done. So it succeeded and is of type standard now, so it's not external anymore. And as you can see, you get the same experience, same input, result, etc., all the same. Potentially like maybe some more metrics because I forwarded them, but otherwise that is really all that it takes to move a model to next move side. And right, so what is the next step? Next step. The next step is I want to now, this is like the bare bones model kind of. It solves, works on an input, solves it, writes the output, like the assignment, and more or less that's it. But now I want to wrap it in a workflow where I actually can create more artifacts on top of it, right? So there's many different use cases for workflows. There could be like ensembling across different solvers or the same solver, or there could be like you have some prediction model that you solve first that feeds into some other model that's solving based on that prediction, etc. So there's multiple use cases for workflows. I'm gonna go into this one because it's visually appealing for a demo, I think. So yeah, let's create a workflow. And for that, I need to say that I already created the demo workflow app. You would normally go here and create a new workflow app. So I also need to define it here code-wise. And again, it's an app, has an app.yaml. It has a main.py describing it. I'll get into that, and the number of dependencies. And this one gets a little more interesting because it uses Plotly, for example, and also NextPipe, which is the workflow modeling framework, basically, that we're using here. Okay, so this is somewhat of a simple workflow. This has 3 steps, and we saw it in the sneak peek already. So the first step is, and when modeling, you need to basically inherit from a flow spec class. And by that, just define your workflow as a class, basically. And every step in a workflow, which is basically a node in this directed acyclic graph in the end, basically every step is just a function, just a normal Python function. And you identify it by using that add step decorator. So we have 3 steps in this one. And the first step is fetch the regions. That means this is downloading polygons for these regions that we just saw because the input data doesn't have it. The input data doesn't contain the actual polygon with latitude, longitude. So we fetch that from a separate source. In this case, it's simply I uploaded it as a gist, but obviously you could, integrate with other things here. This is just an example. And this step just downloads it, returns the regions. And then there's another step, which has this add app decorator, which is reaching out into a prepared demo region allocation. Could have been that I, messed something up. So basically this should be demo app 7 actually, but I'm gonna just stick with what I've prepared. And this calls into another app and makes a run there, and then returns the results of the result of that run. And then the last step has actually an app needs decorator, which defines two predecessors. So this step of bundling the assets needs to wait for both of the other steps to happen first, and then it will get the results of these steps. So it will get the result of the solve step, which is our solution, and then it will get the GeoJSON regions, which is the result of the fetch region step. And then we'll use both and fuse them together basically to create a number of assets, which are plots and so on and so forth, which we will see in the console in a moment. So this is how our workflow will look like. And yeah, and then the same basically needs to be done. We need to push up our workflow. So let's go to our workflow folder. And actually, I've prepared something for that, which is basically pushing and a shortcut, because this uses actually an instance, which is a concept I will explain in a minute when I make the run. So let's quickly push the workflow. I'll start pushing the workflow. So this is basically exactly the same behavior as we've seen with a custom app that contains our OR tools model, but now this is a separate workflow app, and that app can, act independently and make calls to the other app, etc. So that is what we're pushing here. And right now I'm pushing the code again, like I did before, except that this time I also tag it, automatically with a timestamp, and actually creating a tagged version basically of the code, and then also the instance, and I'll update the staging instance to use this one. So this is just a very small script so that this happens more quickly. Cool. So let's go here and let's go to the same model. Let's use next move input JSON. And this time, let's pipe it into next move app run -a demo workflow and dash instance ID. And that is staging. I'm adding this because you can have multiple instances. In my case, I have this staging instance, and I want to send the run to this one. Okay, now back to apps and workflows. Like I said, demo workflow app. This is what we just updated, and we can already see that our run is queued here. Now this takes a little bit longer than normally. So let me quickly, it's sitting in queue, will be scheduled to run in a second, and then basically go through. But while we're waiting on this, let me walk you through the instances, for example. So you can see that this instance of staging basically is what I have defined here, which is always nice because you can have multiple ones. You can also define this as default, and I could have skipped requesting it explicitly. But so basically, this instance can have a version ID, and this version ID is what we just pushed. So this is my local time, 1721, that you've just seen me using or pushing it up. So the version is basically our code artifact snapshot, kind of. And yeah, that instance uses that. So we can confirm that way that it's actually running the right thing. Okay, so, oh, cool. It's running. Might take a hot second. Oh, cool. We already have the flow visualization. So yeah, we have the three steps that I just described. You might wonder, why there are two at the beginning, but basically this workflow has two start steps, right? They both don't need to wait on anything. The solve can immediately operate on the input that I just uploaded. So the input is the same, right? That is sent to this one. And then the fetch region step doesn't actually care about the input, but can still immediately run. And then this bundle asset step needs to wait for both, basically. And yeah, we already got the result. It's basically the same. So that's why I called it meta app. So you can use this workflow app just as you used the other one, just that you now also get like visualizations, for example, of the demand. So we have like a choropleth map plot of the demand of the different regions. So basically yellow indicates, it's there's more demand basically, and then you have like purple with low demand, etc. And then you also see the assignment. So the assignment is actually, to which hub was the region assigned, and yeah, and so on and so forth. And then also you can do other things like using this like Plotly and doing like a comparison of the different hubs and their utilization. So this is basically the demand that a hub can capacity-wise fulfill service, and then compare to what it actually is servicing. And yeah, so basically you can see that obviously it's not caring about, it's not an objective to balance the demand between hubs. That might be something you're interested in. So you could theoretically now play around with it, update your model to also care about that. And then in experiments, theoretically, experiment with different settings of this. Yeah, and that is
Speaking
it.
of experiments, Marius, I created a scenario test under your demo allocation app. I thought it'd be interesting to maybe look at trying this out with different solver providers. I know we're up against time, so you and I can look at the results together, but wanted to see if
Yeah,
that produced anything interesting.
sure. And that is definitely like that's always interesting, right? So basically, Renu can now also use my app because she's part of my team and can make runs here. So the runs that Renu made basically pop up for me as well. And she could have, shared me also the same stuff via link, etc. So I think it's very useful as a collaboration platform to always have something in reference, right, that you can talk about.
Absolutely. Well, thank you so much for that demo, Marius. Appreciate that. I can jump back into the slides here. Okay. So what just happened? Marius went through a lot in a short amount of time here. The first thing we saw Marius do was track an external model run. So a model that an OR tools model that was running on his machine. We were able to track the input, output, and metadata in Nextmove for bookkeeping. Next, he pushed an OR tools model to the Nextmove platform. So then it's actually running on Nextmove and ran it remotely. And then lastly, we saw he created and pushed a decision workflow. So again, we saw the steps, fetching data, running the optimization, creating custom visualizations. And we ran that remotely and saw the results in the Nextmove UI, which were, of course, shareable as well. Okay, as promised, we have a couple of minutes for Q&A. Let me see what's come into us here directly. Alrighty. First question for you, Marius. You mentioned ensembling. Can you explain that again in terms of workflows?
Yeah, for sure. Yeah, ensembling is like a typical thing, especially if you have like a solver that doesn't really is not so stable. Basically, I'm looking for a word right now, but basically, you repeat your run, and you always have like with meta heuristics or other approaches, like random influence, obviously, and then one run might yield a better result than another one. And you actually want to leverage that kind of shortcoming of the solver. You could, and if you have the money and the compute, you could just throw it like 5 times in there and then pick the best result. And that is something where workflows is really helpful because there's actually even a decorator for repeating a step. But either way, you could just, even with different solvers, receive the same input, send it to different sub apps, and then collect the results, merge them, or just pick the best, basically. And that would be ensemble to me, or one use case.
Great. I will sneak in one last question before time runs up on us here. We demonstrated today in the app you showed custom visualizations. We have a question around what other types of custom assets are supported.
Yeah, I mean, at this point, actually would need to check like for completion as well. But we have definitely like GeoJSON, for example. That's what I used here. I also used like Plotly because it's just very natural to me, at least in Python. I think we also have like another charts.js or something library. So for the visual assets, that is because our front end obviously need to understand a little bit and how to handle them. But we're looking into expanding this in particular. And you can think of non-visual assets as well, because, for example, you might be interested in generating just some export data that you then can download via a button. That is also supported. Potentially not everything is in there yet because we're constantly growing that experience and relying basically on feedback. So if you need something in particular, like for example, let's say you're using Excel a lot and want to also export Excel so that a user of yours actually can look at a run and export the results in a friendly Excel format that they can use on their machine to do some post-processing or, whatever, basically. So we would be interested in that.
Yeah, feedback is always welcome and very helpful. And we have one question around providing the code. We will provide the code via we have a repo for examples that we use in Tech Talks, and we will make sure to upload what Mari has demonstrated today into that repo and share that to everybody here. That will be shared. All right, well, we are at time. I want to thank Marius again for the wonderful demo today and everybody who was able to join. Thank you for joining us. If you had a question we weren't able to get to, we'll make sure to email you. And if you have questions that you think of directly after, make sure to email us as well. And you can get started with everything you saw today with a free NextMove account at nextmv.io. And yeah, just want to say thank you again, everybody, for joining, and we will see you next time.